My name is Matthew Alexander. I'm a developer at HCL, and in this video, I'll walk you through the steps needed to run UrbanCode Deploy Server as a container inside IBM Cloud Private. The UrbanCode Deploy Server may now be run inside Kubernetes, starting with version 6271 ifix2 of UrbanCode Deploy. This is available as of March 2018. Before we get started, I want to point out two limitations of our initial release. First of all, we do not support high availability in this release. You may run a single server instance of UrbanCode Deploy only. Also, upgrading a container from one version of UrbanCode Deploy to another is not supported at this time. There are some prerequisites you need to take note of before running UrbanCode Deploy Server in Kubernetes. First, UrbanCode Deploy requires a database. Various vendors are supported, and the database may pretty much exist anywhere. For example, the database may exist in the same Kubernetes cluster as UrbanCode Deploy. You could use an on-prem database, or the database could exist somewhere else in the cloud. As long as your Kubernetes cluster can reach your database, you should be fine. You will also need two persistent volumes in your Kubernetes cluster. If you're familiar with installing on-prem UrbanCode Deploy, you'll remember you need to provide a JDBC driver to allow UrbanCode Deploy to connect with your database. To give your container access to that driver, the driver should be placed on a persistent volume. You'll see us refer to this persistent volume as extlib, since the driver will eventually end up in a directory in the container named ext_lib. The other persistent volume will contain the UrbanCode Deploy app data directory. This directory contains various configuration information for your UrbanCode Deploy server. For example, if you install a plugin into UrbanCode Deploy, it will be stored in the app data directory. We need to persist this directory so that, if our container dies or is restarted, our app data directory will live on and our server will not lose any changes we have made. Some Kubernetes clusters support dynamic volume provisioning. This allows persistent volumes to be created automatically when your Helm chart is installed. If your cluster supports dynamic volume provisioning, you will not need to manually create the two persistent volumes we just talked about. However, the extlib persistent volume still needs to contain your JDBC driver at install time. In order to copy your JDBC driver to the extlib persistent volume at install time, we will use a config map. We will use dynamic volume provisioning and a config map later in this video. IBM Cloud Private is a Kubernetes-based platform, so let's install our UrbanCode Deploy container there. The UrbanCode Deploy image and Helm chart may be loaded into the IBM Cloud Private repositories, as they have been in this demo. Let's take a look at the UrbanCode Deploy Helm chart. Go to the menu, then select Catalog, Helm Charts. Search for UCD. Click on the UrbanCode Deploy Helm chart. The README is displayed, showing valuable information on how to deploy an instance of UrbanCode Deploy. Since my cluster is configured for dynamic volume provisioning, let's check out the sample config map provided in the README. The example config map YAML file is displayed. The name of the config map in this example is user-script. We see the data of the config map contains a script named script.sh. The script checks to see if a MySQL JDBC jar file exists in the UCD home ext_lib directory. If it does not, wget is installed on the container, then wget is used to pull the JDBC driver from a web server. Finally, the driver is moved to the UCD home ext_lib directory. Now, this is just an example to be used for reference. You do not need to host your JDBC drivers on a web server, and you do not need to use wget to copy them over. You may write this script to work in whichever way you prefer. There are a few guidelines you do have to follow. First, the script must be named script.sh. Finally, the JDBC drivers must end up in the UCD home ext_lib directory. On my Kubernetes client, I have created a configmap.yaml file. Its contents are similar to the sample config map from the README. I have changed the name of the config map to ucd-config map. Next, I will apply the config map to the Kubernetes cluster. we see that my config map is running in my cluster. Now it's time to install our Helm chart. Go back to the chart in IBM Cloud Private and click the Configure button. A series of fields appears. Let's walk through them. First, let's give our Helm release a name. I'll name mine UCD-release. Next, specify the namespace of the cluster you wish to install UrbanCode Deploy to. Read and accept the license agreement. For worker node architecture, choose the architecture of your worker nodes. If you leave this field blank, the chart will choose the architecture of your master node. In the image repository field, specify the repository containing your image. If you've loaded the image from a Passport Advantage archive into IBM Cloud Private's image registry, the format will likely be cluster name /namespace /UCD-server/UCDS. Next, enter the tag of your image. You may choose how the image is pulled from your repository, and if your repository requires an image pull secret, you may specify that here. In the service type field, the only option at this time is node port. In the database section, enter the values required to connect to your database. In the initial UCD administrator password field, enter the desired password of the default admin ID. The default value for this field is admin. Under persistence, check the enabled checkbox to ensure your data is persisted if the container dies. If your cluster supports dynamic volume provisioning, check the Use Dynamic Provisioning checkbox. The ext-lib volume section contains information on your persistent volume that holds the JDBC driver for your database. If you are not using dynamic storage provisioning, you must manually create your persistent volumes and persistent volume claims before installing your chart. If you are not using dynamic storage provisioning, enter the name of the persistent volume claim you created to hold your JDBC driver. Be sure to copy the driver to this persistent volume. If you are using dynamic storage provisioning, enter the name of your config map in the config map name field. If using dynamic storage provisioning, you may enter the storage class name in the storage class name field or leave it blank to accept the default. In the persistent volume size field, enter the requested size of your persistent volume. The app data volume section contains information regarding the persistent volume that will hold your UrbanCode Deploy app data directory. If you're not using dynamic volume provisioning, enter the name of the persistent volume claim you created in the existing claim name field. If you are using dynamic volume provisioning, enter the desired size of your persistent volume. If you would like to enforce any memory constraints on your deployment, check the Enabled Constraints checkbox and specify values as you see fit. It is now time to install your Helm chart. Click the Install button. Let's look at the details of our Helm release before we try logging into UrbanCode Deploy. Let's click on our release, then scroll down and click on our stateful set, then click on our pod, and then click on the Events tab. Here we see the pod was missing its persistent volume claims at the start, but then our dynamic storage provisioning kicked in and created 2 volumes. Our image was pulled from the repository, and our first init container started, which performs some initialization actions. Our image was pulled a second time, since my image pull policy was set to always, and our UrbanCode Deploy container was started. Notice the warnings that the readiness probe failed. The UrbanCode Deploy chart includes a readiness probe that ensures the server is running correctly. It is not uncommon to see these warnings as the server starts or is installed. Now let's go back to the Helm release and get our UrbanCode Deploy server's URL. If you scroll to the bottom of the release, you can run the commands provided in the Notes section to receive the URL. Alternatively, in the Service section, determine which port is mapped to 8443. In my example, it is 31630. The URL would then be https:// the IP address of the proxy node, and the port would be 31630. Let's run the commands from the notes section to get the URL. Here's my UrbanCode Deploy server URL. Let's try it out in a browser. I see the UrbanCode Deploy login screen, and it looks like I can get in. Let's go into Settings, System Settings, and fix the external agent URL and external user URL and set them to the value of our UrbanCode Deploy URL. Let's do a quick test to ensure UrbanCode Deploy is persisting our data and reconnects to the database when the container goes down. First, let's install the WAS Deploy plugin. We see WAS Deploy has been installed. Next, let's create a simple process. Finally, let's kill the pod. Kubernetes should detect the pod has stopped and restart it. Let's go back to UrbanCode Deploy and log in. We'll see our test process is still there. And our WAS Deploy plugin is still there. I hope this helps get you started running an UrbanCode Deploy server inside Kubernetes. Thank you for watching.